Good morning for everybody. My name is Corvino, and I'm a doctorate in ICT addressed to electronic and telecommunication field. My research activity is focused on modeling of nonlinear system in automotive application by power and graph technique. My tutor is Professor Roberto Zanasi. So the variable valve timing system is a complex system whose the car are equipped typically in automotive application. The goal of this research is to model the complex system by using the energetic approach technique, and the challenge was the matching between simulated and real signals. How does the variable valve timing system function? So in this picture I'll show you the complex system, because it's composed by an electro-hydraulic valve at the right of the picture. And at the side, I show you the Van Kamp phaser. The system function with the following inputs, like oil pressure and oil flow rate. This hydraulic power flows through the pipes in terms of oil pressure and oil flow rate, reaching the Kamp phaser, pushing on the rotor phases, producing the angular movement that influence on the lifting of the intake and exhaust valves. This lifting of the intake and exhaust valve produce the different breath of the engine cycles, and this is effect on the emission reduction, for example, or to increase the torque at low speed and power increase at high speed. The oil control valve is controlled by a PWM technique, and the control can be studied to control the voltage or the current, for example. In this picture, I'll show you the model of the systems, and we have to split in two by the red dot line the system of representative oil control valve model at left, and at the right the Kamp phaser model. It's important to know the input of the system in terms of oil pressure and oil flow rate, and at the right of the model we have the torque and angular movement. It's important to note that, for example, the constant framed box value, that it allows the transform the power, the hydraulic power, the different power forms to the hydraulic into the mechanical form, for example. So the hydraulic power flows at the starts at the left side of the models and flows through the model at the end of the model in terms of cam torque and angular movement. Briefly, I'll show you some results obtained during the study, noting that at the left side, the pressure, the input of the signals, pressure, and the current applied to the control valve to move to shift the hydraulic power inside the Kamp phaser. And at the bottom of the picture, we show the best results obtained during the simulation. The model was developed by using a Simulink tools at MathWorks, and then there was a hardly study to post-processing the data acquired into the vehicle during the test car, to estimate the physical parameters and simulate and comparison the model. Typically, this model is nonlinear model, and there are a lot of uncertain parameters to estimate. And using another MATLAB tools, it was allowed to understand and to range the uncertain parameters. The future work is to model the oil control valve, because now the model of this component is composed by only a lookup table, and now we to understand, for better understanding the physical systems, it's better to model the oil control valve and to synthesize a controller ad hoc for this nonlinear model. Then we have to make a real-time application for rapid prototyping of the controller before synthesize, and finally to have to value the effect on emission reduction on different controller design. Thank you for your attention. If you have any question, please refer to Roberto Zanasi.